All right, welcome to video 2 of our lesson today. Remember, this is October 2nd, so I'm just trying to keep things straight when I publish these and go back to them. This is the second video of our lesson today, okay? So if you haven't watched the first one, go back and watch the other one first. Okay? We're on this slide. We're 3 minutes after the Big Bang. All right, and energy is slowing down. It's still pure energy, but it's slowing down. And as it's slowing down, it's contracting into clumps. And those clumps are cooling off, and it's becoming protons, neutrons, and electrons. Albert Einstein used this equation, E equals mc squared, to be able to explain how this happens. Okay, how you go from having energy to matter. What this also means is that you can go back the other way. You can go from matter to pure energy. Right? Because you can rearrange the equation and you can solve for any of these. Now C is not a variable. C is a constant. C is the speed of light, and I should know the speed of light off the top of my head, but I don't know. You can look it up. I don't remember it off the top of my head. Anyway, those clumps form into protons, neutrons, and electrons, and those are important. It wasn't so the first 3 minutes of the universe, which seems like a fast amount of time, but it was really a lot going on. And the universe was expanding huge. It was expanding, and it was cooling, and it was the birth of the universe. But about the 3 minute mark, those protons, neutrons, and electrons had started to form. And after about the 3 minute mark, those protons, neutrons, and electrons now have mass, therefore they have gravity. And we'll talk more about gravity later, but they have mass and they have gravity, and if they have gravity, they stick together like a magnet. And so they're coming together. And they're coming together. Gravity's pulling on them. And gravity pulls them. They're still moving really rapidly. It can't pull them together very well, but it's well enough that we can form the first two elements on the periodic table. Hydrogen and helium. I don't have a picture of a periodic table. You should look one up right now and look at it, because the first two elements are hydrogen and helium. Hydrogen has 1 proton and 1 electron. Helium has 2 protons and 2 electrons. And then you get into the other 116 elements on the periodic table. Okay, but right now we only have hydrogen and helium forming the universe. That's it. And for several 100,000 years, it's only hydrogen and helium, which means there's no light. Now there may have been kind of like this weird orange glow from the energy that is still there, pure energy. And the temperature, it's really hot. So that pure energy may have been giving off like an orange glow at the time. But as it's cooling, it's getting darker. There are no stars. There are no planets. There are no galaxies. There are no moons. There are no nebulas. It's just hydrogen and helium. Okay? That's it. And the early universe had a composition of roughly 75% hydrogen, 25% helium. 75% hydrogen, 25% helium. Okay? That's roughly what it was. Which is interesting, because today our universe is roughly 75% hydrogen and 25% helium. It really hasn't changed much. The Earth was hydrogen, helium, the Earth. I got distracted there for a second. The Earth today has lots of other things in it. The terrestrial planets are kind of unique in that way. But the Sun is mostly hydrogen. 75% hydrogen, 25% helium with trace amounts of other things. Jupiter, 75% hydrogen, 25% helium with trace amounts of elements. Saturn is the same. Uranus, Neptune, and they are about the same. You know, like Uranus has a lot of methane in it, which makes it smell like cow farts. So Uranus smells like cow farts, which I can't say with a straight face. But it's true. So, but it's really trace amounts of these other gases. And the Sun has trace amounts of lithium and beryllium and gold and silver and uranium and platinum and everything, all the other elements, trace amounts. And if you look at Alpha Centauri, our closest star, trace amounts. But it's really 75% hydrogen, 25% helium. It's really the same. Okay? So, that's the end of our notes. Okay? I'm going to attempt to close this without stopping the video, which I was able to do. Cool. And I'm going to close this one without stopping the video. No, I'm not. Yes, I am. There we go. Okay. And instead, I'm going to go back to our course. Now, this is your assignment for the day. Okay, this will be due on Wednesday at midnight, which I know is a long time, but I want to give you plenty of time to do it since I'm not there. Go into your astronomy course. Alright, and you have two links here. One is the Big Bang WebQuest site, and one is Big Bang WebQuest, or Big Bang Theory assignment. Sorry guys, I said it wrong. Big Bang Theory assignment. And it says assignments, but it's really only one. You're going to use both of these. The first one is the site, the website itself, and that is this one right here. The link will take you directly to this Big Bang Test tab, where there are 3 links here, and those 3 links are also here with an overview, which is this one. Okay? No, sorry, this one. It'll take you to this one. My bad. 3 links here, 3 links over here with an overview. Now, when you open up the web quest, it's going to look like this. There's a lot of questions. There's 41, but honestly, it's not hard. You'll get this done in 30 minutes if you try. Okay? It's not going to take you a long time. What I want you to do, pay attention here, Part 1, Expansion of the Universe. Well, check this out. Part 1, Expansion of the Universe. You can also go Expansion right here. Expansion of the Universe. You're going to read this, and then you're going to answer the first 7 questions. And then you're going to go to Part 2, Abundance of Light Elements. Well, if you go back here, Elements, it's shortened. If you go back to the overview, it'll take you Abundance of the Light Elements. Okay? And you're going to answer the next set of questions, and then you'll come back to your assignment. And Part 3 is the Cosmic Microwaves. So come back here, and we've got Cosmic Microwaves. Okay? See how this works? It's pretty easy. It's organized. And then you're going to come down and Beyond the Big Bang, and you've got Parts 1, 2, and 3 of Beyond the Big Bang. Well, Beyond Big Bang is this next tab down here, and you've got 3 parts. Parts 1, 2, and 3. Now, feel free to use the rest of this website. Click around on the website. There's more stuff to this website than this. This is done by NASA, so it's full of good information. It's scientifically accurate. It's reliable information. And they do update it and keep it current. So feel free to use this website. Click around on here. Learn some stuff. But you're going to answer these questions and then submit it to me. Now, this is due Wednesday. I'm making it due Wednesday because I want to give you guys class time to ask me questions. So you're going to have class time today to work on it, and then you can email me all weekend long, and I'll be checking my emails. Email me if you need to, and then you have class time. No, I'm sorry. You won't have class time, but you'll have time to ask me questions in class when it's time, okay? So I'm going to stop the video. I hope you guys have a great day. If you have any questions or concerns, something's not working right, email me. Okay, I'll have service all day, or most of the day, hopefully. So feel free to contact me, and we can work through whatever problems you have. Have a great day. Have a great weekend. Make sure you get your assignments done. Also, if you check Skyward and you're missing an assignment on Skyward, or you have a 0 in your assignment in Skyward, email me. I need you to contact me so we can get it taken care of. Your grade is not permanent. If you have a 0 now, it's not permanent, but I do need you to contact me so that way we can get it taken care of, okay? All right. Have a great day. Enjoy your Friday. Enjoy your weekend, and I will see you guys next week.